Okay. Hello, everyone. Let's get started. Please download Laboratory 23 hypothesis testing from Blackboard. And actually, in Lab 22, we have already learned how to do the hypothesis testing. Today, we use another example to show the process. Okay. First, please run the script to identify a hostname, username, contact information, and input your name, a number, title, and the date. Okay. Today, this example is about the here is a you see here is a ACLU of Northern California presented a report on jury selection model in this county, and certain ethnic groups among this one. So we want to perform our analysis on the data given below and examine where there was truly and the representation of certain groups, right? We need to define now an alternative hypothesis and check this model is good or not. The random proportion is close to the jury panel proportions. Yeah, so alternative is not good. So it's good or it's not good, and define it and use your simulation, use your result, use your experimental result to show accept hypothesis or reject this hypothesis. Okay, and here is mathematically how to represent this hypothesis mathematically, right? So you need to calculate the some eligible proportions minus random proportions divided by 2. And the alternative is this one is not equal to the second one, right? So because this one random proportions is because it's randomly selected, so it's based on your simulations, right? And for other things, it's some constant numbers. Only this one is variables. So we need to define it and know how to select this jury and how to calculate this number, right? So we get started. First one, as usual, we need to import necessary packages, NumPy, Pandas, Matplotlib, right? Next one, more data for jury selection. So ethnicity here, Asian, Black, Latino, White, and other, and the eligible number and panel number, right? So it's for the raw data. So we have 3 columns, right? We can use this dictionary to construct a data frame. It's here we have 5 ethnicities and the eligible and panel. We need to find out, right? Eligible proportions and random proportions and panel proportions. So for now, we have 3 different columns, right? Here we need 3 columns. And in this one, we defined the first one and the third one. We only need to figure out what is like a randomly selected proportions, right? So based on this one, based on the data frame, we can plot a horizontal bar chart, right? And panel columns. So you can write and see. Yeah, because for now you didn't set the legends, you didn't set the color, and if you use the data frame, it will have colors defaultly, right? So panel, eligible, different colors. See here, white is very similar, and Latino is panel is a little bit smaller, and Asian is larger, right? So it's just a initial plot about this drawing, right? And next one, we need to get another column. We call it an EP difference. It's called absolute difference between eligible and panel proportions. ABS means the absolute value, right? Absolute value, and you can use this one to get the ABS value and show it. This is the last column, right? So by this way, we open a new column, EP difference. right? So it is AP difference. And then based on this one, we can compute the observed statistics, which is total variation distance between the eligible and the panel proportions. So we need to check the definition here. So because this one is, oh, sorry, this one. The second one, we just called it as the EP difference, right? EP difference. So we can calculate the sum of the numbers and then divided by 2. So that's why here we need to get the results. Here is the EP difference, right? So EP difference dot sum means we sum them together and divide by 2 is total variation. So observe total variance. So it is the result. And actually you need to, if you want to determine accept or reject hypothesis, you need to compare this one with the second one. Second one, we just calculated is 0.114, right? The second one would be 0.14. Okay, so we need to compare something to this one, and then we need to design our simulations to get these random proportions. All right. So any questions so far? Okay, next one is about we randomly picking a sample of size 1453, calculated the total variance distance between the random portions and the eligible proportions. So that as a group, and the total number of the sample size, and another we call it probe, another column. And here we use the random choice. We use it several times, right? And the group from the groups and the total numbers and set the P as PLP, right? And then after that, we can calculate we can calculate the values here. Actually, you can print out. You can print out if you want to see random outcomes, and you calculate which each numbers of them, each numbers of like Asian, Black, Latino, White, and other, and after that you calculate it again, right? So it's about the sample proportion. So it is used to calculate this one, right? This variable. So let's write. It's just a simulation, right? So here you see it is like you selected as like this number, right? This number, and you can write, and the last one would be the proportions of each ethnicity, right? So Asian, Black, Latino, White, and other. It's only one simulation, right? Because it's we do the simulation for one time, and after that here we see we can append a new column, like a random sample panel with the random sample proportions. Right again, so you see here is a random one, right? So last one. It's related to this panel, but it's not the panel. Here is something you simulate. So it's called a sample, random sample. And after that, you plot the horizontal bar again. In this way, you have 3 different bars, right? Eligible, panel, and random. So you see here, the last 2, actually, they are very similar. Yeah, last 2 are very similar because it's based on the randomly selected, right? Okay, so any questions so far? Yeah, understand all of them? Okay. And the next one, we need to calculate the ER difference again, like we do for the panel, like this one, right? So we do it once, but we can do it second times. So also ABS value between this column and the random proportions and do again. So ER, so it means the random, this one E and R difference, this one is EP difference, right? Do this again and calculate this one again to show you for one sample, the sample total variance, the result, right? So it is a result, and you need to compare it with this one, right? And then if it's roughly the same, then they take this null hypothesis. If not, if it's slightly different, then we take this alternative hypothesis, right? So you see here, for only one sample, it's very, very similar, right? Because let me check here. Oh, sorry, it's not different. It's much different. 0.14, but this one is 0.012, right? But it's only one simulation, so that's why here we want to pick like 10,000 samples, and the size is also 1453, but 10,000 samples and do it again. Okay, actually, so here this one is exactly the same as you do it for one time, this cell, right? We only need to put it in the for loop and then 10,000 times, right? We do it 10,000 times. And after that, you calculate a lot of sample proportions and do it again, and get outcomes. And now you can print out the outcome. Actually, I think it's oh, sorry, you need to, yeah, so you see here is it is both the variance samples total variance for 10,000 times, because we append each sample for each one, right? So and we do it for 10,000 times. So that's why here it's 10,000 numbers list. And yeah, so it is about the process of the experiments on the hypothesis. And next one is about the exercise. So you need to do it by yourself. So first one, please complete the rest of analysis with plotting histograms, observations, and calculating p-values. So the first one, you need to plot a distribution of the statistics total variance distance. So it's based on these outcomes, right? So here we pass the outcomes, set the color, and set the edge color and mean value. And then this is the answer for the first step. So I give you the answer, and then you can check. It is a sample about these outcomes. So because it's list of 10,000 elements, so we can use that histograms. And next one, you need to plot this distribution and along with this observed statistics variance. So it means you need to plot this figure in scatter plot of this figure. So for instance, because you have already calculated the value from here, right? And if you remember lab 1012 too, so let me show you. Yeah, so you can check this one. For this one, you plot histograms of a distribution, and next one, based on the distribution, you add one more lines about the scatter plot to show this one. You want to show something you want to compare, right? So this one, I will show you. You need to do it again, but a little bit different. Scatter, and then please finish it by yourself. Okay, so you need to plot this one. in this figure. And after that, compute the p-value to make the conclusion. How to compute the p-value? You need to check this null hypothesis. You need to check the p-value from here, okay? And if you can also check check this one, okay? It's the first example about the hypothesis testing. So you can check here, and then you will know how to solve the question, the third question here, and the answer rejected or not, and answer it. Okay, so it's today's exercise. So I give you the answer for the first question. So you need to finish the second one, the third one, and then have your conclusion. Okay. All right. So that's all I want to share today. And thank you guys. And if you don't have any other questions, please feel free to leave the meeting. Thank you. Check the code before the lab exercise. Sure. You need this one? Okay, yeah. Actually, on your labs, you can see this one. So I only add one more line about print out the outcomes. Okay. Okay, so any other questions? I'll stop here. And if you have any other questions, please send me an email. Thank you, guys.